Hey guys, welcome back to another video. Today we're going to be looking at exponent laws. Now this will either be a review for some of you people or it will be brand new information for others. Either way, this video is here to provide you a better understanding of exponent laws and why they work. Without further ado, let's get started. The first one is when we multiply exponents by the same base, with the same base, we add the exponents. So in this example right here, it's algebra, so a to the power of x times a to the power of y is equal to a to the power of x plus y. And this can very easily be proven. So let's make it into an example. Let's sub a equals 3, x equals 2, and y equals 4, for example. So let's just rewrite our equation. So 3 squared times 3 to the 4 is equal to 3 to the 2 plus 4, just like that. And we're saying that these are equal because the exponent law tells us, okay, these two have the same base, so our exponents are added when we multiply. That's what the first one is saying, and it can be proven. If we take a look at just this side right here, 3 squared times 3 to the power of 4. This becomes, so 3 squared becomes 9, and 3 to the power of 4 becomes 81. I'm going to leave it at that, and we're going to take care of the other side now. So then this becomes 3 to the power of, so 2 plus 4, so 3 to the power of 6. And we're going to leave that at that. And then pull out your calculator and do the math. So 9 times 81, we get 729. Okay. And then 3 to the power of 6 is 729. The answers are the exact same because the law proves this. So to summarize the first one, when we're multiplying exponents by the same base, so any base to any exponent multiplied by any base to any other exponent, the exponents simply just add. B to the x plus y. Just like that. And that's the first law. Now, something that many people do, even people who already know this, and it's a very common mistake, is that they believe when you add bases, you also add the exponents. And that is completely wrong. It's easily the most common mistake. Even if you know this, it's still something that like clicks in your head and you still believe it's right. For example, if I have a to the x plus a to the y, a lot of people will think that this then becomes a to the x plus y. And we know that's not true because when we multiply them, that's when we add the exponents. And we can also prove it's not true. So again, let's sub a equals 3, x equals 2, y equals 4, just like that. And let's write our equation. So 3 squared plus 3 to the 4, and we're saying it's equal to 3 to the 2 plus 4. Now, let's take a look at each side. We already know that this becomes 3 to the 6, which then becomes 729, which is correct. 3 to the 6 is that. But what happens to this side? We get 9 plus 81, which equals 90. These two are not equal values. And that's why this is such a common mistake, because a lot of people will see, oh, they have the same base and an addition sign, so I'm just going to add the exponents. That's not what happens. It's a very common mistake, and I'm teaching it to you now so you don't make it on tests or exams or anything like that. But that wraps it up for the first exponent law. Let's get into the second. Okay. So if we're saying that when we multiply exponents by the same base, and I'm actually just going to go ahead and write all of our exponent laws right here. So the first one was a to the x multiplied by a to the y gave us a to the x plus y. We add the exponents. So if we are saying that when we multiply, we add the exponents, so what must happen when we divide? Well, let's try it out. Let's try a to the x divided by a to the y. When we multiply, if we add, that means when we divide, it means we must subtract. So this becomes a to the x minus y, just like that. And again, I'll show you guys an example. This time, let's say a equals 2, x equals 3, and y equals 4 again. And let's just sub it in. So we have 2 to the 3 divided by 2 to the 4. And we're saying it's equal to 2 to the 3 minus 4. Well, let's do the math. Let's take this one all by itself. So 2 to the 3 becomes 8, and 2 to the 4 becomes 16. So 8 over 16, which is just 1/2. And then this one right here becomes 2 to the power of negative 1, which is just 1 over 2. And they're equal. And it works out perfectly. And for those of you that are like new with exponents, don't worry about like the negative exponents and stuff. I'll get into that in hopefully another video. But for right now, this is true. And that is our second exponent law right here. When we have a base to an exponent and we're dividing it by another base, or sorry, the same base to another exponent, we simply just subtract the exponents, just like that. So b to the power of x divided by b to the power of y is equal to b to the power of x minus y. And we proved it. So this right here is our second exponent law. Now, finally, let's take a look at the last exponent law we have, and it is when we have an exponent to another exponent. So just like that. So a to the x all to the power of y. Well, what happens here? And we don't even really need to prove this, but I will anyway. But this becomes a to the power of x times y. So once we have an exponent to an exponent, we simply just multiply them. And why, you may ask? Well, I'll show you. We know that when we multiply exponents, we add the top, right? Well, let's take a look at this. Let's sub in some values. So a equals 2, I don't know, x equals 3, y equals, let's do 5, just for a change. So, we have 2 to the power of 3 to the power of 5, just like that. Let's do 2 to the 3 first, because brackets first, so this becomes 8 to the power of 5, just like that. Okay, but let's think about this for a second. What is an exponent? Well, an exponent is multiplying a number by itself the exponent number of times. So if I have 2 to the 5, it's 2 times 2 times 2 times 2 times 2. We're multiplying 2 by itself 1, 2, 3, 4, 5 times. So that's essentially the same thing here. And you know what? I'm actually not even going to simplify it. I'm just going to show you. So if we're saying we're multiplying this whole thing by itself 5 times, so it becomes 2 to the 3 times 2 to the 3 times 2 to the 3 times 2 to the 3, that's 1, 2, 3, 4, one more, times 2 to the 3. So now I'm hoping you guys see what happens. Well, we see from our first law that these all have the same base, so we add the exponents, right? Because they all have the same base. So this becomes 2 to the 3 plus 3 plus 3 plus 3 plus 3. Just like that. Since they all have the same base, we add the exponents, so we added 5 3's. Now, 3 plus 3 plus 3 5 times is the exact same as saying 3 times 5, right? Because multiplication, what that is, just a quick recap, is if I'm saying 3 times x, for example, I'm basically saying x is being added by itself 3 times. That's what 3x is, right? So we're basically saying 3 added by itself 5 times is 3 times 5. Well, if we look at this, 3 times 5, that's what our exponents are. And that's what goes back to the first law, that we multiply the exponents. So that's really it for exponents. Those are the 3 exponent laws, just like that. And I'm just going to write the third one now. Just like that. So these are the 3 exponent laws. A to the x times a to the y is a to the x plus y. Same base, when we multiply, we add the exponents. When we divide the same base, we subtract the exponents. And when it's an exponent to an exponent, we multiply the exponents. And that's it. Now, some things to remember. Exponent laws only work for same bases. If I have 3 to the 2 times 2 to the 4, for example, I can't really do exponent laws here. I can't say that this becomes 6 to the power of 2 plus 4. That's not how it works at all. Only if they're the same base, then can we do something like that. So to make this actually equal, first that would be completely wrong. This would have to be 3 to the 2 times 3 to the 4. And then that becomes 3 to the 2 plus 4. Sorry, that's a 4. Like that. So only ever, for the first two at least, only ever when it's the same base can we do that. When it's an exponent to an exponent, you could really do it anytime, it doesn't matter, as long as you're expanding it fully. But that's pretty much it for today's video about exponent laws. If you guys have any math concepts, even physics concepts that you want me to go over, leave them in the comment section below. I hope this helped, and have a great day.